It's easy to forget that what's going on out of sight, inside the pot, is just as critical to the growth of our plants as what we can see. What makes up the root environment? Remember that plants need light, water, nutrients, gases, and warm temperatures to thrive. Each of these, even light, plays a part in the dynamics and health of the root environment, even though it's underground. Within the pot, the media, peat moss, perlite, vermiculite, or whatever, is a matrix that holds and connects all the other pieces. We choose the planting media based on characteristics like structure, porosity, water holding capacity, cation exchange capacity, and pH that affect its ability to both hold and release air, water, and nutrients, as well as to support the plant itself. All these pieces are so interactive that it can be hard to pick them apart and talk about just one at a time, but I'll try to simplify it as much as possible. Even though they're underground, the plant's roots still need to breathe. Just like the rest of the plant, they need oxygen for cellular respiration. Air is held in tiny pockets called pores that form between the solid particles of the media. When the media is packed too tightly into a pot, there's less space between soil particles and the pores are smaller. That means less air is available for the plant. When water is added to the media, it moves into the pores, pushing the air out. As water flows, the force of gravity pulls it down and eventually out through drainage holes in the pot. Absorptive forces in the media also hold some of the water in the pore space. Smaller pores have a stronger absorptive force, so media with small pore sizes will hold more water and less air than ones with large pores. If the media drains poorly or not at all, the pores will remain full of water, and the plant will suffer because the lower roots won't have access to the air they need. Now, what comes out of the tap isn't just pure H2O. Water is a great solvent, and lots of other molecules are dissolved in even the clearest tap water. Whenever you add water to the media, you're also adding dissolved mineral salts. Sometimes we add those salts on purpose. Remember that plants need minerals like nitrogen, phosphorus, potassium, calcium, and iron in order to thrive. When these nutrients are present in the soil as mineral salts, the roots can absorb them. While field soil is made of finely crushed minerals and often contains a lot of essential plant nutrients already, most soilless potting mixes are nutrient poor. We add nutrients to the media with fertilizers. Fertilizers can be solid compounds that slowly disintegrate and release nutrients into the media, or they can be dissolved in the irrigation water and added to the media as the crop develops. Just like it can hold water against the flow of gravity, the media can also cling to the mineral salts that are plant nutrients. The cation exchange capacity, or CEC, of the media is the measure of its ability to hold nutrients and release them to the plant. How tightly the media clings to certain mineral salts can vary depending on its pH. The preferred pH range for soilless media is slightly acidic, or between 5.6 and 6.2. Outside of this range, the media clings so tightly to certain minerals that although they may be present in the soil, the plant can't pull them away from the soil particles. Since mineral salts get dissolved in water and move with it, water can also be used to flush excess salts out of the media. This reduces the salinity of the media, which can be bad for plants if it's too high, but too much of this leaching can flush away valuable nutrients before the plant gets a chance to use them. Don't forget that the plant itself is an active part of this dynamic system. The plant is acting on and reacting to the environment. Changes in temperature and light affect the rate at which plants absorb water, nutrients, and air from the media. Low light and cool temperatures will slow the plant's rate of growth, and it will need fewer resources from the media. Brighter light and warmer temperatures mean faster growth and depletion of the nutrients and water in the soil. It's critical to be aware of the complete growing environment and adjust your water and fertilizer practices accordingly.